Okay, we are looking at the math methods written exam number 1. This is without the CAS, and we're going to look at the work solutions. So let's get to it. So the first part here, question 1, find dy dx, and we're going to do a product rule, differentiation. So we separate the functions and find their derivatives. There we go. And then find the derivative using this construction of the product rule, uv dash plus u dash v. So this is like a cross multiplication of the 1, 2, 4 functions we've come up with and their derivatives. When you substitute, use brackets like so, and you can see clearly we've got all the 4 parts together using brackets. What we have to do is expand properly, especially this bit here, this x squared plus 1 is going to multiply the 4e to the 4x, because our goal is to express your answer in factorized form. So we expand it out, and then we collect a highest common factor, which is 2 and the e to the 4x. Okay, and there's the factorized form, so that there gives you your 2 marks. Next question. Okay, this is a quotient function, so we're going to use the quotient rule differentiation. So u is the top function. Now notice here, log of x squared, that's a little quadratic inside a log. We don't have to treat that with a chain rule when we differentiate it. We can use a log law. The 2 as a power can come out as a multiple of 2 at the front of the log, and it's 2 times log of x. And so the derivative is just then 2 lots of the derivative of 1 on x, so it becomes 2 on x. And we get v equals x squared at the bottom and differentiate it. Alright, let's put it together using the quotient rule. There it is. The structure of the rule is always v times u dash. So the v function here is what comes first, times u dash minus u dash times v, u times v dash, and then we divide by v squared. Expand out, simplify the numerator. Any common factors in the terms? There's a common factor of x in each term, and we can take out a factor of 2. There we go. So from that, we're going to now evaluate the function at e. Now we substitute x equals e into our more simplified function, our derivative function. Now this part here, the log e of e, that's an important thing that can simplify. That goes to the number 1. So then you've just got a 1 minus 2 in your numerator, which is negative 1. And the negative 1 is times into 2, and we've got a e to the 3 in the denominator, which can be expressed just like this with a negative power. Okay. Question 2. We are sketching this graph. Now, recognizing this graph, this is a truncus. So a truncus has this kind of general shape with a horizontal and vertical asymptote. We're going to identify the asymptotes from the equation. The 3 is the horizontal y asymptote, and x equals 1 is the vertical asymptote. So let's sketch the asymptotes. We can sub x equals 0 into the function and evaluate that to get the y-axis intercept. So that's this point here. And then symmetrically opposite that same point, on the other side of the vertical asymptote, there's an equivalent point that is 2 grid units apart on either side of the vertical asymptote, and we can very accurately sketch the truncus this manner. Okay, so they're the main features you need to show to get full marks. You've got to put the equations of your asymptotes there and there, just like so. Okay. Now, find the area enclosed by the graph and the lines x equals 2 and x equals 5 and the x-axis. So the area of the function, the area of the truncus function, is going to be between 2 to 5. They're your limits. And integrating goes to this integral function. This here is a bracket to the power of 2 that's in the denominator. This is a power term, so consider that as a negative power, negative 2 power, where adding 1 to negative 2 becomes negative 1 power, so it's just an x minus 1 on its own in the denominator, in the integral function. Okay, evaluating this, substitute the 5 in, evaluate, and then subtract, and then substitute the 2 in and evaluate, and we get 21 on 2 units squared when we simplify it. Question 3, we've got the function which is log base e of cos of x. Okay, across this domain 0 to 2 pi. Find the equation of the tangent to the graph. So the tangent, the gradient of the tangent to this graph is the same as the derivative at this point, x equals pi on 4. So let's differentiate it. We're doing a chain rule, so the inside function cos, derivative of cos goes to minus sine, and then the outside function is log. The derivative of log is 1 on the u, which is the function cos of x. So we substitute that back in and we get negative tan of x. Okay, now we want to know the derivative at this point, x equals pi on 4. So we substitute pi on 4 into the tan function, and that is, tan of pi on 4 is the number 1. So the gradient of the tangent will be minus 1. We've got to get the y coordinate at this x coordinate, x equals pi on 4. So we sub x equals pi on 4 into the original equation itself and evaluate to get a y coordinate. We're getting log of root 2 on 2. Okay, here is the formula to get the equation of a straight line. So gradient of minus 1, x equals pi on 4, and the y1 is going to be log of this root 2 on 2. We expand and simplify and we get our equation. Negative x plus, and then now we've got to distribute this negative, so that minusing of pi on 4 becomes an addition, and that whole number there is like your y-intercept of the tangent. Alright, so what else can we do? Hence, find the angle from the positive direction of the x-axis to the tangent of the graph. So an important thing about an angle of a straight line hitting an x-intercept, this is the tangent function itself. So for a gradient of minus 1 of the tangent to the curve, we can use the tangent trig ratio to work out the angle. So the angle is the inverse tan of the gradient of the line, which is going to give you a 3 pi on 4. Alright, what about x values of stationary points? Alright, of the function. Well, this is when the derivative is equal to 0, so the derivative was the negative tangent of x. When that goes to 0, we're going to solve for x. So x is, now this here is an important thing to remember, the general formula for the solutions to a tan equation. N pi plus the inverse tan of the value. Alright, inverse tan of 0 is the number 0, so x is just a multiples of pi. So we've got x equals 0, pi and 2 pi across the domain. However, when we check with the original f of x, okay, then x equals pi is an issue, because when we sub x equals pi into the original function, that being this guy, log of cos of x, if we put a pi there, cos of pi is negative 1, and then log of negative 1 is undefined, and that's not good. We don't want an undefined value, so we can't use x of pi. So that means only 0 and 2 pi are the valid stationary points. Alright, so the next question, question 4. Class containing 5 boys, 10 girls. The teacher runs a 4-question quiz at the end of each lesson and selects a student at random to answer these questions. The teacher can select the same student to answer any number of questions. So that means the same boy could be selected 4 times in a row. So this is not the same as a random sampling from a population. Okay, because every time you do a random sampling from a population, you randomly sample without replacement. But here is a scenario with replacement because the same boy can be selected more than once. So what's the probability that the number of boys selected in a given lesson is 0? So first let's define our random variable. B is the number of boys selected. We want to find this, the probability that B is equal to 0. Okay, so no boys selected. Well, there's only one outcome of that. That is, when a girl is selected on the first time, a girl is selected on the second time, a girl is selected on the third, and a girl is selected on the fourth. So these are all intersections of events. So what's the probability that a girl is selected? Well, that will be 10 out of 15 altogether. But there's 4 occasions of that, so we have that probability to the power of 4. 10/15 is 2/3. It's important to be able to simplify fractions. If you can't do it at year 12, you're in trouble. And then to the power of 4, 16 on 81. What is the probability that at least one of the students selected in the lesson is a boy? At least one. Okay, so that means probability that B is greater than or equal to 1. And we can use the complement rule, which is equivalent to 1 minus probability that B is less than 1. So what discrete number of B is less than 1? Well, that's when B is 0. And we know that. That's from the previous question. So 1 minus probability of B equals 0 is 1 minus 16 on 81, which is 65 on 81. Little subtraction of fractions there. Now, part C, what is the probability that no boy is selected in exactly 3 of the 5 consecutive lessons? So now we're looking at a number of lessons. Give your answer in this form. Now that form is a whole number times the probability to the power of something times probability to the power of something else. So that could be like a binomial distribution type problem, especially because we've got n number of 5 trials of selecting a boy. In this case, no boys. So let's define the binomial random variable x. It's the number of days of no boys selected. X is a binomial random variable. Probability of selecting no boys is from the previous question, 16 out of 81, for 5 number of trials. Okay, so we're solving this. For exactly 3 of the 5 consecutive days, x is equal to 3. So we need number of combinations of 3 into 5. Probability of success to the power of 3, probability of failure to the power of 2. So all we have to do is evaluate 3 combinations of 3 out of 5 things. So it's important to know this rule. 5 factorial divide 3 factorial multiplied by 5 take 3 factorial. Expand out all the factorials. So 5 times 4 times 3 times 2. Okay, cancel out any common factors, and we get 10, whole number 10. And there it is. So that's the way we need to express our answer, just like as written here. Wow, alright, pretty good. Next question. Question 5, we've got now log of 1 minus x squared is our function, and we've got to find the maximal domain. So that's when the stuff on the inside of the log, that's got to be greater than 0. Can't have log of a negative number. So 1 minus x squared is greater than 0, subtract the 1, divide by negative 1, remember to flip the inequality. So when is x squared values less than 1? Well, that's when they're all in between minus 1 to positive 1. Okay, so there's our maximal domain. Next question, we've got this g of x, same function, but now it's restricted from a minus 1 to 0. Okay, so it's almost like half the implied domain. And we have to find the inverse function. So we sub y is equal to x. and we transpose and try and solve again for y pronumeral. So we do the exponential, e to the x. We rearrange to get y squared by itself. So the next step is to do the square root on both sides. Now, can't have both positive and the negative square root together, but that's essentially what it's equivalent to. Okay, this is a relation, that's not a function in itself. So we go to now check with the domain. Check with the domain to make sure that we're going to choose the correct plus or minus sign on the square root. So an important relationship, the range, we got to consider the range of the inverse function. It's the domain of the actual function itself. So the domain goes from a -1 to 0. They're all negative numbers. So that will end up being the range on the inverse function. Okay, so the range on the inverse function, the y values we're after for our function, is going to be -1 to 0. They're negative numbers overall, so we're going to have the negative in front of the square root as our value. Get it? Alright, the next part is find the domain and range of the inverse function. Well, the domain of an inverse function is the range of the function. Okay, we don't know that yet, but let's try to do the easy one first. The range of the inverse function is the domain of the original function, which was that -1 to 0. We did that. Alright, and if we inspect the equation, we could figure out that the range goes from a -infinity all the way up to a 0. Especially because of the log equation. If we get log of fractions, they are negative values. Okay, so it all from negative values all the way up to 0. Now let's construct the next rule. This is a composite function we're constructing, h of k of x. So we simply sub the k of x function, this -1 minus x squared, into the exposition of the h of x rule. And we just get this square root of 1 minus e to the -1 minus x squared equation. Nice, easy. Now, the next question was to determine the domain of this. So, an important idea is the domain of a composite function. Well, if this composite function is defined, if it exists, okay, then what we get, if it exists, then simply the domain of the composite function is just the domain of the inside function, k of x. And it exists, it's defined when this occurs, when the range of the inside function is a subset of the domain of the outside function, h of x. Okay, so when that occurs, and we're told that happens because we said we were told that the function was defined itself. So when it's defined, then the domains is simply this relationship here. We just need to consider the domain of the inside part, the inside function, this k of x. So, what is k of x? K of x is this -1 minus x squared. Well, how do we make sense of that? That's like a parabola, an upside down parabola. It looks like this. So normally parabolas just continue on for all x values. So, therefore, the domain of the composite function must be all real numbers. Very good. Next question, question 6. Okay, so now we've got a sine function restricted from 0 to 2 pi, and we've got to find the x-axis intercepts. Okay, so we let y is equal to 0, and we start solving. We subtract 1 and do the inverse sine. So when it comes time to evaluating this gives us angles, inverse sine of -1, it gives us angles for 2x values. So how big are 2x values for which we are to find angles from? Well, twice the x is twice the domain. Twice of 0 to 2 pi becomes 2x is 0 to 4 pi. So we're going to consider 2 revolutions of a unit circle when finding angles. So what are they? One is √3 on 2, and the other is 3 pi on 2, and the other is 7 pi on 2. Okay, that's in the second revolution, this one here. Okay, then solve for x by dividing by 2, and we get 3 pi and 4 and 7 pi and 4 as our x-axis intercepts. Calculate the average value, calculate the average rate of change of the function over the interval. The average rate of change, that's our A-rock. So it's the difference of the functions divided by the difference in the x's. So do a substitution. There we go. Substitute 2x and 0 into the functions and simplify it down. Divide by 2 pi. And we're going to get 1 minus 1 in the numerator. Okay, that's 0 as an average rate of change. Alright, so then calculate the average value of the function between the x-intercepts. So that's from part A, the x-intercepts. Alright, so that is 1 over the difference in the intercepts, and the integral of, from the 3 pi and 4 up to the 7 pi and 4 of the function that we're trying to find the average value of. So carefully doing our subtraction, 7 pi take 3 pi is 4 pi. 4 pi on 4, well that's 1 whole pi. So we get the reciprocal of pi. Integrate our function, the integral of 1 goes to x. The integral of a sine function goes to a negative cos with this factor of 2 comes out as a half at the front. And we're going to evaluate it at the endpoints. So we substitute in the top numerator, the top number 7 pi and 4, and then we subtract and substitute in the bottom number 3 pi and 4 and evaluate. We need to know values like cos of 7 pi on 2 and cos of 3 pi on 2. That goes to 0, both of them. We get average value of 1 when we evaluate that carefully. Okay, almost there. Question 7. So, company produces batteries for calculators from 2 different machines A and B. 4% of batteries produced by machine A are faulty. 5% of batteries produced by machine B are faulty. At the end of the day, machine A produces 50 batteries, machine B produces 80 batteries. Company owner selects 1 battery at random from all batteries produced in that day. Okay, we've got a number of events. The batteries could be faulty or not faulty, whereas the second event is we could select from machine A or we could select from machine B. They're complements of each other. So let's define the events carefully. F is going to be the battery is faulty, so that means F dash could be not faulty. Okay, then let's say event A is selecting from machine A, whereas we could write machine B, which is selecting from machine B, and A and B are going to be complement events to each other. So, part A, what is the probability that a battery selected is faulty? Probability of F. So that is total rule of probability. F given A times probability of A plus F given B times probability of B. Okay, well, F given A is faulty from machine A. Well, that's that 4%. But probability of selecting from A, well, that's 50 out of 130. Let's do the same for B. This is going to be probability that it's faulty from machine B is 5%. Okay, and selecting from B is 80 out of 130. Simplify these fractions. We can 50 divides into 100, goes twice. 2 into 4 goes 2. 2 divided into 130 is 65. So we get 1 on 65 and 2 on 65. Add them together, 3 on 65. So that's now the probability of F, faulty. Next bit, battery is selected and found to be faulty. So we know now faulty has occurred. That's like a condition. Okay? What's the probability that the faulty battery was produced by machine B? So we want B given faulty. So we got to find the intersect of the event and divide by the probability of what's given. There's the conditional probability formula. So the intersect can also be found by f given b times probability of b, and that's something we've determined previously. Sub in our values for probabilities, simplify it down, and we're going to get 2/3. So review those fraction work very carefully there and prove to yourself that you get down to 2/3. Okay, question 8. Now we've got a continuous random variable, probability density function looking like this, and we want to maybe work with this, evaluate some probabilities. The first thing we got to do though is prove this differential is the case. So the derivative of the left hand side it's a product rule. So this is u dash times v plus v times u dash. Okay, expand it all out and collect your terms. That e to the 2x is a common factor. Bring that and then the x e to the 2x term by itself, and that there is this right hand side. That's what we wanted. Alright, good. Next we're going to find what's the probability that x is less than a quarter. Well, first off, that's the integral, integrating from 0 to a quarter of the function. Now this structure here, okay, we got to relate that back to what we noticed in the previous question. So in the previous question we've got a situation where we've got the derivative of something is equal to these two terms, and in fact this second term here, that one, that looks the same as that, and all we have to do is make the b number equal to something. Let's let b equal to the number 2, and it will be exactly the same. Does that make sense? Okay, so we started that. We're going to let, for b is equal to 2, we substitute that in, and our derivative rule used as a formula from part A becomes this. And we transpose and we rearrange for that term, and we get that 4x times e to the 2x is equal to this expression now. Alright, so that was just purely taken from part A for substituting b is equal to 2 and rearranging for that last term. There it is. So we substitute that into our integral now. So we're doing the integral of this right hand side here. So the integral of the derivative is an easy thing to do. And then we've got the integral of this, negative 6 e to the 2x. And we get this becoming our integral formula. So now we have to just substitute and evaluate the terms carefully. So we sub in our quarter, and then we subtract, and then we substitute x equals 0. Perfect. Simplify it down, and we're going to get this as our final expression. So practice that, make sure, see how well you can get it. And then part C, show that the median value m of x is a solution to this equation. Okay, well, what's the definition of median? Median is the middle number, that is the probability up to the median value must be 50%, halfway, the middle number. Okay, so the probability up to the, or probability less than the median number is going to be a half. So this probability statement here is an integral, the same as something like this in the first question, something like that. So the integral from 0 to m of the probability density function is going to equal 2.5. There it is. And we know what the result is when we integrate where this kind of expression, we're integrating this, it's the same as the working out we've done here. So this line there we can draw in as the result. Okay, but now this time we're just evaluating from 0 to m. Sub it in again as before. Yep. And now we've got to expand it all out carefully. Bring all the terms over to this left hand side like shown here, so it's now equals 0 on the right hand side. Keep going. We've got terms we can collect. This 2 times e to the 2m minus 3 times e to the 2m. They're common terms and we subtract. There we go. We get the negative. We're almost done. I'm going to do a little multiplication trick. Times by -2 on both sides into each term, and I get exactly the equation that I needed to prove. And we did it. And we are finished. Finished. Well done.